Cryosphere remote sensing. Welcome to the cryosphere, yet undiscovered for many humans. Those portions of Earth's surface where water is temporarily or permanently frozen. Either ice, snow, glaciers, frozen ground, etc. A beautiful and incredibly huge part of the planet, which plays a big role in the global climate system. Remote sensing allows us to see beyond its natural barriers.
Nowadays, scientists are studying the cryosphere very carefully in order to understand how much the climate change affects the melting of frozen water. It is a very serious problem that mankind has to face, since many human lives and ecosystems are at risk. Because of the extreme environmental conditions and remoteness, remote sensing constitutes a unique tool for exploring a cold region.
Studying the cryosphere with remote sensors, we can obtain helpful information such as displacement and density of glaciers. Glaciers are one of the most sensitive indicators of the Earth's climate change, as they have an important stabilizing function inside the global environment system. This means that any little variation makes the difference. For example, carving processes of floating ice suppose a considerable additional discharge of grounded ice. The more density it has, the more the sea level rises. Radar sensors help us to analyze them precisely, as different glacier surface conditions influence in their own way the strength of the scattered signal. Concentration of frozen sea. Sea ice typically emits more energy than the surrounding ocean, which makes it easy to distinguish between the two with the appropriate sensors. Snow cover and snow water equivalent. While snow cover is an important parameter in the global climate system due to its impact on the light reflected by the surface, snow water equivalent is a quantitative variable needed by most hydrological models. We can measure them with advanced systems. Thickness of the sea ice surface. Radars and lidars send pulsed radio or light signals towards the Earth and measure the time it takes to return to the sensor. The round-trip time determines how far the sensor's distance to the reflecting surface. With the sea level as a reference, the sea ice surface height can be determined, which scientists use to calculate the total thickness of the sea ice. If we know where the thinner sea ice surface is, we can route ships through ice-covered regions. As we said, cryosphere is crucial to understand our changing climate. The explanation is simple. When solar rays hit snow and ice, approximately 90% of it is reflected back out to space. As more snow and ice melt, the ocean and land that were underneath are exposed. This absorbed energy is then released as heat to the atmosphere. This effect is accelerated even more when the methane trapped in the melted frozen soils is released into the atmosphere, a powerful greenhouse gas that keeps the heat near the Earth's surface. According to a recent scientific study, if this situation persists, there may be no more sea ice left in the Arctic Ocean during the summer in the next few decades.